Hello, hope everybody's having a good day. Today we're going to be talking about graphing systems of linear inequalities. So one of the first things we need to remember that how to draw our lines. If we just have a greater than or less than, that means the points on that line are not included in the solution, and we have to use a dotted line to represent that. Now if there's an equal sign, that means the points are included, so we want to use a solid line to represent those. So one of the ways that I think helps make these a little bit easier if you're trying to think about which way to shade is to always have in slope-intercept form and have the y on the left-hand side. So if you have something listed as greater than or equal to, that means you're going to shade on the side that you can walk on, or the top side. So notice, with a positive slope, that's the side we would shade. A negative slope, that's the side we can walk on. Zero slope, that's the side we can walk on, so we would shade on those sides. And now for a vertical line that has no slope, the numbers that are bigger go that way, so we would shade on that side. So that's a special case. Now for less than or equal to, we would shade the side that we can't walk on, or the lower side. So positive slope, that side. Negative slope, that side. Zero slope, that side. And for no slope, this is where the numbers get smaller, so we would shade that way. And we're interrupted. So we might see some other functions that we need to shade as well, or not functions in that circles case. So for quadratics, if it's greater than and it's opening up, you want to shade on the inside. If it's opening down, you shade on the outside. And circles for greater than, you shade on the outside. Less than would be all the smaller circles on the inside, right? And then absolute value is just like quadratics. If it's greater than, you would shade. If it's opening up on the inside, if it's greater than, you would shade on the outside. It's opening down, and you would flip that around if it was less than. So let's take a look at our first problem here. So what we need to do here is just graph these and figure out where the solutions are at. So we got y is greater than 1/2 x minus 2. So I'm going to go down and graph that. So I'm going to go down to -2 and put a dot. So 1/2 x minus 2. And that means up 1 over 2, right? Rise over run. Whoops. There we go. I'm going to go back 2, down 1 as well. So notice this was a greater than. So that means we need to make this a dotted line. So greater than means we would shade on the side that we can walk on. So instead of shading everything, I'm just going to draw my little man there. So I know that that's the side I should be shading on. All right, so how about the next one? We got -3/2 x plus 2. So I'm going to go positive 2, put a dot. I'm going to go down 3 over 2. Looks like I can go back 3, or I'm sorry, back 2, up 3. And now it's a less than or equal to, so that means it's a solid line. I'm going to draw my line the best I can. And less than means the side we can't walk on. So if we imagine the black line being shaded up and the red line being shaded down or backwards, the overlapping region is right here. So that's where all of our solutions for this system lie. And remember, since the red line is solid, all of those points along that line are included in the solution. And with the dotted black line, that's telling us those points on that line are not solutions. So let's try another one. This one's in slope-intercept form. So let's graph 4x plus 3. So we're going to put a dot at 3. Now I need to go up 4 over 1, but I can't, so I'm going to go back 1, down 4. It'll be a really steep line. And this is greater than or equal to. So that means it's going to be a solid line. I'm going to go and put one more point to try and make this line a little bit straighter. All right, not horrible. So since it's greater than, this is the side we can walk on. So we're going to imagine that being shaded. So now let's do the -2x minus 3. So we're going to go down to -3 and put a dot. So -2x means over 1, down 2. Then I can go back 1, up 2 to kind of hopefully make a line a little bit neater. All right, so now I'm going to connect my dots. So greater than or equal to means the side we can walk on. So that would be this side. So if we imagine the red line being shaded, to the right and the green line being shaded backwards to the left, our overlapping region would end up right here. So this is where all of our solutions are. And any of the solutions along the lines are included there because they are solid. So here's another one. We got x plus 3. So we'll put a dot 3, go up 1 over 1, up 1 over 1, back 1 down 1. And I'm just going to do this again, make my line hopefully a little bit straighter. So this needs to be a dotted line, right? Because there's no equal sign. And less than means we would shade the side we cannot walk on. All right, so negative 3x minus 1. So that would be, down 3 over 1. So I'm going to go back 1, up 3. 1, 2, 3. Back 1, up 3. And then down 3 over 1. Now I'm going to try to make this line. So it's less than, so that means we got a dotted line. So there's our dotted line. And less than is the side we cannot walk on. So we'd be shading that side. So imagine that blue line, the whole underneath of it being shaded, and the red, the whole backside of it being shaded. The overlapping region would end up right here. So that's where all of our solutions are. And none of the points along the line are included because they are dotted. All right, so the next thing you might need to be able to do is you might have to get them in a slope-intercept form. So we're going to use red to represent that one. So the first thing I'd want to do here is I'm going to want to subtract 2x from both sides. So here you get y by itself. So I've got negative y is less than or equal to negative 2x plus 3. So now we got to get rid of that negative. So I'm going to multiply everything by a negative 1. So when we multiply by a negative 1, hopefully remember, whenever you multiply or divide by anything, you have to flip your inequality. It's going to change the sign of everything. So now we have y is greater than or equal to 2x minus 3. So let's graph that one. So I got, here's negative 3. Slope of 2x be up 2 over 1, 2 over 1, up 2 over 1. So now I'm just going to connect my dots the best I can. Notice it's solid because it's got an equal sign. And since it's greater than, we would think about shading the side that we can walk on. So let's use blue for the next one. So we got 4x plus y is less than 3. So pretty easy. We just got to subtract 4x to get it in slope-intercept form. So we got y is less than negative 4x plus 3. So I'm going to go up 3, put a dot. Down 4 over 1. I can do one more. Down 4 over 1. Now this line needs to be dotted because it does not have an equal sign. If we're doing this on paper, we could actually use a ruler. So less than is the side we cannot walk on. So if we imagine the red line being shaded to the left, blue line being shaded to the left as well, like down, our overlapping region would be right here. So that's where all of our solutions are. They go on forever. All right, so I'm going to give you guys, pause this or something and try this and see how you do. So the first equation, we would say we need to subtract x from both sides. And now we need to multiply everything by a negative 1. So we'd have y is greater than or equal to x minus 3. It's the same thing here. We got to fix that guy. So we're going to subtract x from both sides. So we'd have y is greater than or equal to negative x minus 1. All right, so let's graph these guys. Oops, didn't switch my colors. We're going to make this one green. Second one will be green. So let's start off with that guy. Down 1, put a dot. Down 1 over 1. Back 1, up 1. Just need that negative slope. So greater than or equal to would be a solid line. Do the best I can with the solid line. There we go. And greater than would be the side, side that we can walk on. There's my guy. So the blue line, x minus 3, greater than or equal to. So I'm going to go down, oh my gosh, it's going crazy. So here's x minus 3. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And it is greater than or equal to, so I am going to connect my dots. So greater than or equal to is right here. So the overlapping region would be right here.